We know that the Sun and its system of planets, which we call the Solar System, were formed about 4.5 billion years, but we are not at all sure how or where the system was born. The popular theory on the subject says it likely happened near a supernova, but a new theory introduces another element into the mix, a wolf-rayet star. Compared to a star like the Sun, which has a life of about 10 billion years in its current state, wolf-rayet stars die out in the blink of the cosmic eye. These live fast, die young explosively. Stars have a life cycle of only a few 100,000 years. They are quite massive, many times the mass of the Sun, but typically lose half that mass in under 100,000 years, according to NASA. They end up as the supernova of a very special kind, and the material produced in the explosion travels out into space, becoming the building blocks for future stars and planets. Even before they go supernova, wolf-rayet stars are losing mass. They burn the hottest among all stars and produce large amounts of matter that is flung their way in the intense stellar wind. The stellar wind and the ejected material combine to form bubble structures with dense shells, inside which gas and dust become trapped. A Hubble image showing a few of the tenuous threads that comprise SH 2308, a faint and wispy shell of gas located 5,200 light-years away in the constellation of Canis Major. Photo S. Hubble NASA. Because the gas and dust can condense in that closed space to become stars, the shell of such a bubble is a good place to produce stars. Nicholas Dorfus from the University of Chicago, who is a co-author of a paper describing the new theory, said in a statement Friday. The researchers base their theory on the fact that, compared to the rest of the two isotopes in the early solar system occurred in very unusual proportions. Meteorites from the time show an abundance of aluminum-26 and a relative dearth of iron-60. Supernovae produce both isotopes, making the discrepancy noteworthy. Vikram Dwarkardis from the university, another co-author of the paper, said, "It begs the question of why one was injected into the solar system and the other was not. Wolf-rayet stars provided a possible answer because they released a lot of aluminum-26 but no iron-60. The idea is that aluminum-26 flung from the wolf-rayet star is carried outwards on grains of dust formed around the star. These grains have enough momentum to punch through one side of the shell, where they are mostly destroyed, trapping the aluminum inside the shell." Dwarkardis explained in the statement. An illustrated model shows our solar system and its planets. Photo NASAJPL. Eventually, gravity caused part of the shell to collapse, and that formed our solar system. The star itself either exploded as a supernova later or directly collapsed into a black hole, depending on its initial mass. According to the theory, between 1 and 16% of all Sun-like stars could have been formed in the bubbles from wolf-rayet stars. The paper appeared Friday in the Astrophysical Journal.